All right, so let's take a look at 21. All right, 21 said, this one is a little bit harder. We haven't done this one, so this one might be a little bit more difficult. I'm not going to give this to you on a homework quiz. All right? What this one means is that we have to distribute that power of 2 to everything in the parentheses. So this is one you would have had to kind of be like, what would make sense for me to do? We haven't gotten to this power rule yet. So this would be 2 squared times x to the 2 times 2, which gives me 4x to the 4th power. So that's a preview of a power rule we'll be getting to. All right, but that's that one. What else can I do from the CUDA worksheet? Christiana? 13? Okay. 13 is one I would give you on a homework quiz. So I have 7v to the 3rd times 10u to the 3rd v to the 5th times 8u times v to the 3rd. Is this the one you're talking about? All right, so Christiana, whether it's 2 terms that were multiplied together or 3, we still do exactly the same thing. All of this is multiplication. So I'm going to move next to each other my numbers that I can multiply together. Everyone's taking a look at number 13, please. And then the variables that I can move together, I'm going to put them in alphabetical order. So u to the 3rd times u to the 1st times v to the 3rd times v to the 5th times v to the 3rd. And now I'm going to multiply. So 7 times 8 is 56 times 10, which gives me 560. U to the 3rd plus 1, v to the 3 plus 5 plus 3. So that would be u to the 4th and v to the 11th. What else can I do from the CUDA worksheet? All right, how about the 4.7 worksheet? How about worksheet 4.7? Are there any on here? Angela? 27? All right. So 27 had us look at 6 squared, all raised to the 2nd power. And I'm comparing that to 3 to the 4th times 2 to the 4th. All right. So I need to simplify each of these. The challenging thing about 27 is, on the right side, do these two terms that we're multiplying together have the same base? What do you guys think? No? Okay, they don't. So I cannot use my power rules here. So while on like number 23, number 22, but basically all the rest of them, we are comparing numbers that have the same base, which means all we really have to do, other than 24 and 27, all we really need to do is simplify using our power rules. The problem with 24 and 27 is our numbers that we're comparing don't have the same base. So I actually have to do the multiplication. I can't leave these in exponential form. All right, so for 6 squared to the 2nd power, this is 6 to the 2 times 2, which is 6 to the 4th. And I would have to multiply that out. 6 times 6 times 6 times 6. So this would be 36 times 6. So 36 times 36 is going to give me 1,296, and I'm comparing that to this. All of you are taking a look at number 27, please. I have to just do this math. So off to the side, I have to do 3 to the 4th, which is going to give me 81 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 4 is 16. So now I have to do 81 times 16, and this also gives us 1,296. So these are equal. So when we have numbers with the same base that we're comparing, we can use our exponent rules. But if we don't, we've just got to fall back on doing the multiplication. All right, I do want to go through with you number 44 from page 207. So everyone skip to number 44 on page 207. We had several like this. So for those of you that did not get this right, you were not paying attention to the examples that we did in our homework and in our notes. And I don't know what to tell you. All right, they give us the dimensions of 4x and 2x plus 2. And they say find the area. How do I find the area of a rectangle? Alex? Length times width. So I have area equals, all right, so I have 4x. Let's say that's our length. What's our width? What's our width here? This is not a trick question. Here. So can I just do this, you guys? Is that all I need to do? Who thinks no? What mistake have I made? Kira? I do. So how do I indicate that I have to use the distributive? Why do I have to use the distributive property? Yes. What do I have to multiply together? Yeah, I have to multiply 4x times this entire expression. How many of you guys understand that? So to accomplish that, Kira, you're absolutely right. I have to put that 2x plus 2 in parentheses. You have to. If I don't put it in parentheses, then all you're multiplying together is the 4x and the 2x. Pierre, you're paying attention. If you don't put that expression that is our width in parentheses, then all you're multiplying together is the 4x and the 2x. And you have not multiplied that length times the entire width. So that has to go in parentheses. So now I can use my distributive property like Kira said. So I have 4x times 2x, bring down that addition, plus 4x times 2. Now I'm going to do that first part. I have 4 times 2 times x, which gives me 8 times x to the 1 plus 1, which gives me 8 times x squared. And I'm going to add to that, well, I'm just going to move those like numbers together, that 4 times 2 together, because I can actually multiply those. And I could simply get 8x. Can I add 8x squared and 8x? Can I add 8x squared and 8x? Come on, you all should know the answer to this. Can I add those together? Layla? Why? Why are they unlike, sweetie? Exactly. I cannot add these together because this 8x is 8x squared. This is simply 8x. So Layla is exactly right. These are unlike terms. Cannot add them. Now the biggest mistake that I see are people just move things out of the parentheses without doing your multiplication. And you can't do that. You have to do that distributive property. Questions on this problem? Okay, you guys have a homework quiz. Get a piece of paper out and a pencil. Emerson, I want you to try and take it. And we'll see how you do, and then we'll decide if we're going to keep